Alright, welcome back guys. So this is the second video we have for lesson 5.2. We are going to do example how to find the indefinite integral from using the substitution method. So I've got three examples here I want to go over. So in the first one, we're looking at the integral of e to the negative 3x dx. So keep in mind is we have these antiderivative rule that we learned last lesson. And our goal is, when we do this type of substitution method, our goal is to try to get into one of these form here, so that way we can apply the antiderivative rule. So recall, this is just e to the u plus c. This is just u to the n plus 1 over n plus 1 plus c. And this is just the natural log of u plus c. So that's our goal, is to get these indefinite integral into one of those forms using the u substitution method, so that way we can find the antiderivative quick and easy. So let's start with part A. So we have a composition function of e to negative 3x. So the outside function is going to be e to the x, and then the inside function is going to be negative 3x. So we can use one of the rule that we learned a while back if you have e to the negative 3x here, but I want us to practice with u substitution from this lesson here. So let's start with just identify what would be our inside function. So I'm going to go with minus 3x here, and then du, the differential u with respect to x, is going to be minus 3 times dx, right? All right. So now we can plug that into the given integral. So we have this here now become integral of e to the u. So notice that we have just dx there, but our du say that it must be equal to minus 3 dx. We only had 3 dx. So what we can do here is solve for dx. So if we divide both sides by negative 3, we should have dx equal to minus 1/3 du. Okay, so now dx is going to get replaced. So this dx here is going to get replaced by, negative 1/3 du. Okay, so times negative 1/3 du. So now we can put out that constant. So negative 1/3 comes out in front. E to the u du. What is the antiderivative of e to the u? It's just going to be e to the u itself plus some constant c. We can now replace what u stand for, and u, we had let u equal to be negative 3x, so it's going to be e to negative 3x there plus some constant c. And that's going to be your answer. All right. You can check that on your own there. Let's go on to the next example. Okay. So the next example, again, we have to identify. Okay, well, first of all, notice that this integrand here is nothing like we seen before with the antiderivative rules that we learned in 5.1. So our goal is to turn this into one of this here. Can we do that? Okay. Well, let's find out. Okay. So let's identify what is our u function would be. I'm going to go ahead and just let u to be the x squared minus 9. Okay. Then our du differential is going to be 2x dx. Okay. Now notice that this part here is going to be u, but then we have this dx x left over to replace by du. Well, du is 2x dx, so we have an extra 2 there. So what we want to do in this case is divide by 2. So we have 1/2 du is x dx. Okay, so the x dx here, this x dx is going to get replaced by 1/2 du. So now the integral of x over x squared minus 9 dx is equal to 1 over u, because x squared minus 9 is u, and then the x dx now get replaced by 1/2 du. And again, this 1/2 can be brought to the front, so we have 1/2 the integral of 1 over u du, and that's using this rule here. So the integral of 1 over u is going to be the natural log of absolute value u plus c. So we're looking at 1/2. U was x squared minus 9. So 1/2 natural log of x squared minus 9 inside the absolute value. But x squared minus 9, well, that can be negative. Depends on what x is. So that's going to be our answer there. Okay. All right. Let's move on to part C. I'm going to go ahead and erase this here for part C. Oops. Right. Let's see. So I'm looking at this here, 5t squared times t to the third plus 4 raised to negative 2 power. So I'm going to look at this as the inside function that I'm going to let my u equal to is going to be this t to the third plus 4. So differential u is going to be 3t squared dt, right? So notice that we have 5t squared dt, okay? But we have 3t squared dt. So how are we going to make this work? Okay, so how are we going to insert a phi there? Well, let's see what we can do here. What we can do is we can first divide both sides by 1/3. So we have 1/3 du is t squared dt. But what we want to replace is 5t squared dt. We don't have 5t squared dt, but what we can do here is we can insert a phi both sides like that. So we can take that and multiply both sides by phi constant. So that will give us 5/3 du is now equivalent to 5t squared dt. Okay, and that should do it. That should be what we need to replace the 5t squared dt with. Okay, let's go ahead and do that. So the integral of 5t squared t to the third plus 4 raised to negative 2 dt now is equivalent to u to the negative 2 times 5/3 du. We can factor out or put out the 5/3 in the front of the integral. So we're looking at u to negative 2 du. Now we're going to use the power rule of the antiderivative. So we're looking at 5/3 u to negative 2 plus 1 divided by that new power plus c. So we're looking at 5/3 divided by negative 1. So we're looking at negative 5/3. And then u to negative 1 plus c. Let's replace what u equal to. U was this here, t to the third plus 4. So negative 5/3 t to the third plus 4 raised to negative 1 plus c. And now our final answer, we can rewrite this as negative phi over 3 times t to the 4 plus t to the third plus 4 plus c. Okay, so I'm gonna let you guys check the work there to see if that's gonna take the derivative of this, see if that's gonna give us, you know, the answer right there. Okay, all right. Okay, there is another example I want to go over. This is probably really long. I might just do this in a different video.